Question 3, and here we're straight into a trig equation, a quadratic style trig equation with cosec squared of 2x minus cot of 2x equals 1. Remember, it's the squared trig functions that you can change. You've got to keep the linear one, the linear trig functions in there. So cosec squared we can change using the identity 1 plus cot squared theta equals cosec squared theta, and remember you can generate that from sine squared plus cos squared equals 1 if you need to, if you can't remember it. Okay, so we're going to use that identity. Cosec squared theta is then equal to 1 plus cot squared theta. Sub that into here, and we've got 1 plus cot squared 2x minus cot 2x equals 1. Okay, tidy that up a little bit, so subtract 1 from both sides, and we're left with cot squared 2x minus cot 2x equals 0. Well, that's a nice factorization then. Just simply factor out the common factor of cot 2x. And we're left at the one bracket situation there. So cot 2x equals 0, or cot 2x equals 1. Okay, so there's no inverse cot on the calculator, so we're going to have to turn it into tan. So cot, remember, is defined to be 1 over tan, so 1 over tan 2x equals 0, or 1 over tan 2x equals 1. Now, this is an interesting situation because if you sort of rearrange this, I'll take the reciprocal of each side here, what do we get? Well, over here we're going to get tan of 2x equals 1 over 0. Now 1 over 0, of course, would give you a mathematical error. Now when do mathematical errors happen on a tan curve? Well, that would happen at the asymptote. Okay, and where's the first asymptote on a tan curve? So let's draw the tan curve now, so we can remind ourselves of that. Okay, and we can see then that the first asymptote is at 90 degrees there. So that means that this is effectively telling us that the tan 2x is the 2x, sorry, is at 90 degrees. Okay, from that, so that is saying that 2x equals 90. Or of course, it could be the next asymptote there, 270, or indeed the one after that, which would be at 450, etc. So when you're dealing with multiples of angles, in this case 2x, just list lots of answers for yourself, and then you can divide them all by 2 later, and check that then the final results are within this domain. Over on this side we had a 1 over 2x equals 1. Reciprocal of both sides there, we have tan 2x equals 1 as well. Okay, now tan, so you might know the inverse tan of 1 is going to be 45 degrees. Inverse tan of 1, that's 45 degrees. So that's telling us that 2x is equal to 45, or this point here, which is 45 degrees above 180, so that's 225, or this point here, which is 45 degrees above 360, so that's 405, etc. And that should be plenty. Given that we've got quite a small domain, 0 to 180 there, we're not likely to need, well, we'll only need 2 of these in actual fact. Okay, so now we're ready to divide through by 2. So divide through by 2. X then over here is going to be 45, or 135, or 225. Although 225 is beyond the domain there of 180. Okay, so we can then cross that one off. And over here we've got, if we divide through by 2, that's going to be 22.5, and 112.5, and 202.5, but 202.5 again is above 180, so we're going to cross that off. So our final answer then, in order, 22.5 the smallest, then we've got 45, then we've got 112.5, and then we've got 135. And there we go.